Hey everyone, happy Friday. Today we're going to continue chapter 12, section 1, focusing on examples 3, 4, and 6 from your book. And really, not much is changing, except we're now going to be focusing on one-sided limits. So we've been going from the right and left. What if we only need to go from one direction? So one-sided limits. I don't know what I'm spelling, limits. And we'll start with left-hand limit. So essentially, if the value of f of x approaches the unique number L, so we're just going to label it L, as x approaches C from the left. Okay, then that would be written the limit as x approaches C, but we need to make sure we're saying from the left, and left values tend to be negative, so we're getting lower, so we have a negative when we're talking about something to the left. And then we say of f of x, and it's approaching L. So this whole thing is a sentence saying the limit as x approaches C from the left of f of x is equal to L. All right, so then let's talk about right-hand limit. So if the value of f of x approaches a unique number let's call this one, I don't know, M, as x approaches C, from the right, then we would write it the limit as x approaches C, and then from the right we do a positive sign. And then it's still of f of x, and we said it's approaching M. And then that's our sentence. So there's an existence of a limit C, which is what we've been doing if L and M are equal. All right, so let's just do an example. Estimate each one-sided limit let's do estimate each one-sided or two-sided. If it exists. All right, so we're going to do the limit as x approaches 0 from the left of f of x. Let's just say what f of x is. And f of x is going to be the absolute value of 3x over x. Then we're also going to do that same thing but from the right. So it'll be as x approaches 0 from the right of the absolute value of 3x over x. And then we want to know, well, does the limit as just x approaches 0 exist? And in order for this one to be true, from the left and from the right have to be approaching the same thing. So this is from the right. This is from the left. Okay, so for the left and right, you're going to make a table. But our table doesn't have to be as big because we're just going from the left. So we're going to have 0 and then 3 to the left of that. So that'll be 0, and then we need to choose 3 to the left, so that would be -0.001, -0.01, and -0.1. And then we're going to substitute in values, or these values, and see what we get for our output. So 3 times 0 divided by 0, well, that's undefined. Okay, here you get -3. Here you also get -3. Essentially, you get -3 for all of them. So then from the left, right, that means we're approaching 0 from the left. And then what are our y values doing? Well, it looks like they're approaching -3. So then from the right, we're going to follow the exact same, except it's from the right. So then we have 0, and then we need 3 values to the right of that. So I'm going to do 0.001, 0.01, and 0.1. And again, substitute it into your function. So we get undefined. And then we get 3, 3, and 3. So as we approach from the right side, going towards 0, the y values here are going to 3. So because they're not going to the exact same thing, then we conclude the limit as x approaches 0 of f of x does not exist. Right? So this does not exist, but these do exist. So if you remember back from the first chapter, that is going to be a jump discontinuity. So from the left, looks like this at -3, and then from the right, it looks like this. Okay, so the limit as it approaches 0 does not exist because they're not going to the same thing, but from the left it does exist. It's approaching -3, and from the right it also exists and it approaches +3. So I want to talk about one more thing. Okay, unbounded behavior. Or unbound. So what unbound behavior is if a graph goes to positive or negative infinity, that is considered to be an unbound limit. The limit is said to be, and then there's 3 different options. So option 1, if our function, say this is an x value c, in our function, oops, looks like this, then this would be the limit as x approaches c of f of x. It would be going towards infinity, right? From the left and the right, it's going up towards infinity. Then we have something like this. Say this is our c value, and it could do something like that. So this is the limit as x approaches c of f of x is going towards negative infinity, because as we go close to c, it's going down. And then the last one, still considered unbound. Say that this is our c value, is if it's going in opposite directions. In this case, the limit does not exist for the limit as x approaches c. But from the left, it's going towards positive infinity, and from the right, it's going towards negative infinity. So you can still have left and right hand limits. So hopefully that makes sense. Work on your homework. And then if you have any questions, please come to flex time next week, or just do some work during flex time and see if any questions pop up. Seniors, congratulations. This is your last lesson of the year. And you'll have your quiz on Tuesday.